In this video, I'm going to talk about object and classes in Python for CIS30A, and this is the second part for week 4 lecture. For Python, it is an object-oriented programming language, so very much like C++ and Java, you will be able to incorporate class and object within the class. Now, there's some slight difference in how you would use constructor in the class and how you would be able to access the object, but there's some similarity between Python and the other languages. So to start, let's define an object. Simply, an object would contain data. Data from variables, and also it's allowing you to have methods that would tie to that object. Think of it like it would be able to group the data that would be stored in the variables in that particular class, and also the methods or the functions that would be stored for that particular class. And the class is a blueprint of an object. So for an example for this, an analogy for this would be, think of an object as a house. And when you have a class, when you're defining a class, you're defining a blueprint of your house. Like how many rooms it would have, where are your doors and windows, how many doors would be built into the house, where are the hallways, the dimension of each room. So when you lay out a class in a program, you're really building out the blueprint for that object. And in our case, this object could be a house. And in that house, we would have rooms, we would have windows, we would have doors, we would have the number of floors. So using the object, we would be able, using that house, we would be able to evaluate or see how many rooms that house would contain, and how to access those rooms, and what would be stored inside that house. So basically a class, it prototype that particular object. And so the house is an object. We would see the floors, the doors, the windows as it's described here. So when you define a class, you use a class keyword. And class, what it does is it creates a namespace, and where all the attributes that are defined is going to be tied to that namespace. And attributes are simply data or functions. So when we're saying that we're accessing the attributes for that object, basically we're just going to go to the location, right, of the memory where that object is identified, and be able to look at the data which was stored inside that variable for the class, and which are members, and the methods or the functions to be able to operate within that class for that object. So for example, if we wanted to, going back to our house, we can look at the number of rooms that it would have for that house, and the house is the object. Or we can look at, even in attributes can tie to how to be able to count up the number of rooms in that particular house. So now, some of the things that we really have to define and understand is that as soon as you define a class, right, when you have that class, then a new class object is created using the same name. So if I have a class called, in our example, person, there's a class object that would be created under that same name. And that class object would then allow you to access the attribute that is instantiated in that class. So what that means is, in this class, once I created this class person, and this is the constructor, I would then be able to use the object to be able to access the name of the person, and the age of the person, which is the data that is stored for that particular object. So the class object, which is P1, allows us to be able to access the attribute inside that class that was instantiated for that object. So now in the second part here, it talks about an object is called an instance of the class. So in the process of creating an object, we would instantiate that object. So an object P1 here is an instance of the person class, and it would then allow us to be able to access again the attribute inside that particular object. So here we have init function, and the init function is used to create a new object, and we would know that as a constructor. It constructs the object. So if a house is an object, init function is a foundation of that house, right? It would be the foundation of that house where we would lay the posts so we can start to begin to build that object. So the init right here, the function allows us to really construct that object and also incorporate the attributes for that object, or the instance variable for the object. So here what we see is we have three parts to the constructor. The self, you can use any identification here in this part. Think of this as a placeholder. So by practice, many of the programmers in the industry, Python programmer, they would use self, because self really points back to the actual object for that class, the class object. And also you would have the instance variable. So you would have the self.name is name. So we would reassign that as name. So we would have name here. And then also age, that would be the attribute for that object. So in the argument, we would use self, name, and age. And if you have more variables to be incorporated, like ID, hair color, gender, etc., you would then add that as part of the arguments. So the self parameter is really a way that we would reference the instance of that class, which is a way that we can access the variables that belong to that class. And name belong to that class, age belong to that class, and these are the variable that belong to that class. Inside the parameter, as I mentioned, it is used to access the variable, and then the self just basically represent the instance, and we would use self keyword. But again, since you can use other reference identification word there, but it doesn't. Most of the time you would see that by practice they would use self. So the reason why you would use self is that it does not use the at syntax to refer to the instance attribute. Python is a little bit different than the other language that way. If you don't use self, it might not receive it automatically. So the first parameter, as long as that first part of the parameter, this is really a placeholder, so it would then be able to receive that of the class object as instance. So next we're going to talk about object methods. And these are the methods that would be, or functions that would be incorporated for that object. So in the earlier example, we started talking about these as we would have the constructor, and then in the first parameter, we talked about self, name, and these are the variables or the instances for that object. Next, we would talk about the methods. And simply we would define our method, whatever that you would call the method here, but importantly, since you're using the self here, you need to bring it down and use it as a parameter for the member method. And in our method, we simply print out, hi, hello, my name is, and then we would plug in the name, so it's going to access the instance for the object, and it's going to plug that in there. So in the class, simply we just have a location where we would tie in the data that had been initialized for specific variable, and how the method would use the data to operate to give you the entire program. And notice that you would have indentation after you declare your class. So when you declare your class, you would have class, and we would have the class name. And by practice, we should use capital letter for the first letter in your class name. You can use lowercase, but that's not best practice. And then you would have a colon. And so here we declare that class. Then we have a constructor. And then here we would have the instance variable. Then we would have the instance methods. And you can have as many as you wish to be able to deliver the goal for your program. Next, we would have the object, which is P1. And often you would see that the object, the way we name this is we would declare our object using like one letter or a letter with the number. You can use similarly to using like a name, like how you name a variable. But how do we know it's an object? Number one, we would bring down the class name here, and then as for our arguments, we can put in the name and the age for that person. And then when we call the method, when we're accessing the method for that object, we simply bring down that object name. We use a dot operator, and we would call the method there. So this allows us to access the instance method for that object. So based on the discussed example, what we have is the program now. And what you see here is you would have the object, which is P1. And here we would be able to implement, we can add in the name and the age of the person as how it would be constructed up here. And when we print, when we need to print, we can print the object and the name, the object, and the age. So we'll be able to access the name for that object as we print, and the age for that object as we print. And then the output for that, we would have Jane 30. So you simply, once you create the object, you can use that object to access the attribute, which is the data that would be stored in the instance variable, or you can operate the method with that. So in this one, we simply use the instance variable. In the next one, I will talk about how you can incorporate the rest using another example. But on this important to point out on page 6 of your notes, it talks about class definition cannot be empty. So you cannot leave it blank, but in the case where you have to, then you can use the pass statement to avoid error. Oh, just move it on to the next part of your code. And so the self is the parameter in the function that the user can use another parameter name in place of it. As I talked to you about that earlier, you can use self or you can use another name. However, by practice, we want to use self. So here is another example of using class. And in this one, unlike the last one, I do not have a constructor. I simply just have, or the init, actually, I have a constructor, but I don't use the init function. So in this one, I have a class, and my class is declared as dog. Within that class, I have the two members variable at attr1, which is declared and initialized as mammal. The second variable, attribute 2, it's assigned dog. And then I have a member method called fun, and then I would use self inside the parameter for that method. So that allows us to be able to access, right, the actual, to implement this method so that way our object can access the method down the line. So here we would place the self, and then we would print I am a, and we wanted to access self attribute 1, which is going to say I am a mammal, and then we then print again I am a dog. So for the driver code, we create an object. We instantiated the object Roger, and Roger is part of the dog class. And so we created the object here. Okay. Now to print, then we can simply print out dog, and then we can also access the method. So in this part, that shows us that we actually access the class attribute, which is from here, and we access the class method. So when we run this, it's going to say mammal, I am a mammal, I am a dog. Why does it say mammal? Is because we have it print mammal here, and then when we call on the method, it's going to say I am a mammal and I am a dog. So first we access the attribute, which stores the data for the object, and next we access the method, which retrieves some of the attribute and be able to print that out for us. So I wanted to show another example in which I would be able to define a class and then be able to incorporate the constructor using multiple methods to be able to access the attributes for that object. So this one, I have a class called car, and we wanted to construct and construct the object and also instantiate the members variable and also the methods for that class. So first, what we have is we have a class called car. We declare a class called car, And again, don't forget that you have to have a colon. Now, then we have an init method to be able to instantiate our attributes here. So we have model and color. Now, next we would declare and define our method. So we have a method called show, and this is a method of that class, car. It is a member method, and using that method, we wanted to be able to display the model. We want to access the attribute again, and the color of that car. The next part, we have an object, and we name this object Audi. And it is an object because here you would use the same class name as what you previously declared. And we would be able to implement the arguments in that parameter for the constructor there. So we would have Audi, A4, and blue for model and color. So it's going to plug in this into here for the A4 and blue for the color. A second object that we have is Ferrari. And for Ferrari, we have the model Ferrari 488 and green for the color. So it's going to append this into here for the model and green for the color for the second object. Then we would be able to access the method for each of the object in the next line. So we have Audi.show. That's gonna show the model and the color for Audi as the object. And then next we are going to display Ferrari model and the color, which is green, for the Ferrari. So when we run this, we're going to see that first it's going to say the model of the Audi is A4 and the color is blue. That's going to be this part here. Then next, we are going to display the model of the Ferrari is 488 and the color is green. And that's this part here. So in this one, what you can see is that we have a class. We constructed the objects to be able to access the attributes and the method of that class. So when you have a class, when you declare a class, the members variables and the member methods or functions belong to what's known as a class suite. And that would be including members, components, statements of, and attributes for that class. And a class is used to create the class objects. You can have multiple objects, as what we've seen in the last example with the Ferrari and the Audi with car. And it would not be complete unless we would have some kind of functionality, and the functionalities are defined by setting attributes for that class. So to expand from what we talked about a little bit further, your class attributes are data members, which are instance variables and methods. The class variable is shared by all of the class instances and object. The instance variable, different from the class variable, is that it's only unique to an instance of the class, where the class variable can be shared across all class instances and objects. Compared to instance variable, it's only unique to one particular instance. So make sure that you look this over and also examine some of the program that you will be writing for the lab, and also the portion of your course project required that you use class and multi-class. So for a final exam, there will likely be questions about class variable and instance variable. And in our lab, we address the difference between the class and the instance variable. For our method, it's defined in the class as what you've seen in the last example. It defines the behavior or how that object should be used. With the class attribute, it would then belong to another object, and it could be accessed using the dot attribute notation. So when we're looking at our attribute, we can have the attribute in like this: p1.name or p1.age, and that will be accessing the attribute. And if you need to access the method, it would then also use the dot operator. You have the object and the method, and the object and the method. So the difference between the attribute is that attribute is from the variable, and the accessing the method, the member method for that object, is the actual method itself. And you know that it's a method using the parentheses following, and we define that here using the EF. So for class attribute, it is a functional element that belongs to one object, and it can be accessed. And data attributes, it could be a list and dictionaries that would have functional attributes. So when it's data attributes that really pertain to list and dictionary, that will be functional attributes. So for the class attributes, you can access that using the object, or the class attributes can be linked in which how they would be defined. Now, the instance data attribute is the primary that would be used for that particular instance. Every object has its own copy of the instance attributes. So in the next example here, it shows you how you can access attributes, and you can update that. So here we access the attribute, then we would modify it, and then we print it again, and it would give you the output, which is 11. And then for the next part, this shows you for the class attribute. So I'm going to display that in C. So in this example, we have a class called sample class, and our class attribute is here. We declare count is initialized at 0, and we have a method called increase, and what we're going to do is we are going to increase it by 1. So for our object, we have an object created called S1. It's constructed the object there, and what we have is we would access the method here. We would then access the method for that object, and then we would print it. In the second part of the program, we have a second object called S2, and we would also access the method for that object is increase here, and then we would print that, and accessing the attribute, the class attribute, so we're accessing the class attribute there. And lastly, we would then use our class and access this attribute. So the difference between this part, this is class attribute, and this is your instance attribute. So now what we're going to do is we're going to run it. And it's going to tell us that first it's going to print 1, as it would be for the count here. Then we would increase 1 more as we start from 0. We already increased by 1 to print 1. That was from this line. Next, we are going to take 1 and we're going to increase it by 1. That will be 2 here. 2 is printed for this line, line 16. Then lastly, we will print for the sample class. That would be accessing where count is now stored at 2 as updated. It would then have 2. So as you can see, this is an example of how you would use class attribute. We first declare that up here, and then we update it throughout by using the method. And as it accessed the method, it also updated our attribute for the entire class. So in this example, I want to talk about instance attribute. This is what you find in the notes on page 8. So in the example, we have a class called imp. And for our class, we use the init function to be able to have the attributes, the instance attribute included. So here we have name, and we initialize that as XYZ, a string, salary 4,000. Then we have a method called show, and then we want to print name and salary. We have an object is declared as E1. We created the object here as E1, and we wanted to print out with dictionary form, return dictionary attributes and attribute lists. So when we run this, what we would have is we would provide the dictionary form. We have XYZ. Our name is going to plug in as key. XYZ is the value. Salary is going to be plugged in as key. And 4,000 is going to be plugged in as value. And when we print the directory of E1, it provides the attribute list following that. So it shows us how the attribute would be implemented or listed, included under that class. So on page 8, you can look at the example, and the example gives you a little bit more clear picture on how you would use instant attributes as dictionary attributes, or to be able to print out attribute lists if you want more clarification on which attributes is being used in your class. So this concludes part 2 of the week 4 lecture in CIS30A. Please watch the next part where I talk about inheritance and also local, global, and non-local variables.